Okay, let's just get straight into this explainer. Welcome to the Examiner's Vault. Today, we are doing something incredibly powerful. We are going to engineer the absolute perfect DNA of an A-star answer, literally building it from the ground up. You know the feeling, right? You walk into the exam hall, sit down, the clock starts ticking, and the pressure is just immense. Whether you're tackling Cambridge syllabus 0417, 0478, 2210, 9618, or 9626, there are certain core topics that act as ultimate gatekeepers. And mastering topic 10.1, validate and verify data entry, is absolutely essential. It doesn't matter which paper you're sitting. This concept appears in almost every single examination series. It is the key that unlocks the highest grade boundaries. Today, we're not just reading through a textbook. No way. We are unlocking exactly what the Cambridge examiners are hunting for when they mark your paper. We are going to shift your mindset completely from a stressed student desperately hoping to remember a bunch of random facts into a sharp, critical analyst who engineers an airtight, undeniable response. Because here is the golden equation for computer science exam mastery. Evidence plus analysis equals your A-star. Let's get to work. Take a really close look at this quote. This is pulled directly from the Cambridge Principal Examiner Report, and it is crystal clear. Candidates referencing cross-topic connections achieve significantly higher marks. What does that actually mean for you? It means top-performing students exhibit a deeply connected conceptual understanding that transfers seamlessly to unfamiliar, weird exam contexts. But let's step out of the theory and look at the brutal reality in the exam hall. Imagine you flip the page and see a classic high-stakes past paper question. Evaluate the use of validation and verification when entering data into a new database system. Boom, 8 marks. Now, let me introduce you to two very typical students we see all the time. First up, we have Alex. Alex is our brute force student. Alex sees the word validation and immediately goes into overdrive, overloading the answer with raw computer science facts. We're talking a massive unstructured list of every single validation check under the sun. Range, length, type, format, you name it. But here's the problem. Alex provides absolutely zero analysis of the specific database context. It's just a massive fact dump. Then, on the other end of the spectrum, we have Sam. Sam is the panicked sprinter. Sam rushes the question, completely misses the crucial command word evaluate, and simply writes a couple of sentences describing what double data entry means. Sam's answer is incredibly rushed and totally superficial. So what happens when these hit the examiner's desk? It's an absolute bloodbath. Alex might scrape a couple of marks for basic knowledge but gets 0 for evaluation. Sam gets maybe 2 marks for a basic description and leaves 6 massive marks just sitting on the table. Both of them completely failed to engineer that perfect answer because they didn't understand the DNA of what was actually being asked. So how do we fix this? Here is our roadmap to completely transforming your exam strategy today. First, we'll lock down the core principles and terminology. Second, we'll dive into the method mark strategy. This is an absolute game changer. Third, we're running an interactive workshop on advanced critical analysis. And fourth, we'll expose the top examiner warnings so you don't fall into the same traps as Alex and Sam. All right, let's kick things off with Section 1, Core Principles and Terminology. To decode those tricky command words effectively and build that A-star response, you have to define your key terms with absolute laser precision. Listen, examiners are testing 3 main things: your ability to recall knowledge, apply it to a specific context, and critically evaluate it. If you misunderstand the core terminology right out of the gate, your entire analytical house of cards just falls apart. Let's look at the big two: validation and verification. I know, they sound similar, they both start with V, they both relate to data checking, but mixing them up in an extended response is a fatal error that examiners see constantly. Think of validation as a strict bouncer at the door of your database. It is an automated, computerized check to ensure that the data being entered is reasonable, sensible, and within acceptable boundaries before it is even allowed to be processed. It is entirely about setting rules. Think of a range check ensuring a customer's age isn't entered as -5, or a length check making sure a password is at least 8 characters. Verification, on the other hand, is completely different. Verification is simply checking that the data entered perfectly matches the original source document. That's it. It is a mirror. It does not care if the data is sensible or logical, it only cares if it is accurate to what was originally written down. This is typically achieved through double data entry, typing it in twice to see if the computer flags a mismatch, or a manual visual check against the paper form. If you write the word validation in your exam when you actually mean visual check, you immediately lose the examiner's confidence. You have to lock these definitions in cold before you write a single sentence. Now, this brings us to a massive revelation about how Cambridge actually grades these papers. The assessment framework heavily, and I mean heavily, prioritizes deep, logical, structured reasoning over a superficial spread of facts. You can't just throw everything at the wall and hope it sticks. This is where we introduce the ultimate weapon, the PEAL framework. PEEL. Point, evidence, explanation, link. Top-tier students don't just list facts like our friend Alex did. They meticulously structure their answers. You make your point clearly. You back it up with evidence pulled directly from the scenario provided in the exam. You provide a deep explanation of exactly how that evidence impacts the system. And finally, you link it all back directly to the command word. Think about it. Would you rather submit a shallow, bullet-pointed list of 10 random validation rules? Or would you rather write a deep, structured PEAL paragraph analyzing just 2 specific rules but applying them strictly to the hospital database scenario the question asked about? The examiner wants to see you apply knowledge like an engineer, not just regurgitate a textbook. The PEAL paragraph wins every single time because it proves analytical depth. And honestly, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's keep building this strategy. Moving right along to Section 2, the method mark strategy. This is where we start gaming the system a little bit. Welcome to the transformation phase. This is how we take those bleeding red pen marks from Alex and Sam's failed attempts and engineer them into glorious green check marks. You need to understand that Cambridge papers often award what we call method marks. This means you actually get points for demonstrating a logical, step-by-step procedural framework in your thinking, even if your final, ultimate conclusion is slightly off base. It is a massive safety net. So when you sit down at your desk and the timer starts, you are going to deconstruct every big question using this standardized 5-step sequence. Step 1, identify key elements. Extract the command word. Is it describe, explain, evaluate? And extract the exact context. Is it a school database, a retail checkout system, a nuclear power plant? Step 2, apply principles. Select the correct analytical framework, like validation versus verification. Step 3, execute analysis. This is where you write those beautiful PEAL paragraphs with clear, structured logic. Step 4, verify results. Take a breath, read back over your answer, and verify you didn't wander off topic halfway through. Step 5, present format. Ensure your technical terminology is flawless. Now, think back to our struggling students. If Alex had just stopped at Step 1 to identify the command word evaluate, that generic, zero-mark fact dump would have never happened. If Sam had utilized Step 3's PEAL structure, they would have defined verification, applied it to the scenario, explained the massive time cost of double data entry, and linked it back to overall system efficiency. That step-by-step discipline is exactly how you secure those vital method marks. And let's not forget Step 5, present format. Practical application in computer science means strictly following presentation conventions. It shows the examiner you are developing professional IT skills. It's honestly not just about what you say. It is heavily about how you present it on the exam paper. The syllabus highlights over and over that the presentation of information must follow strict conventions. If a question asks you to design an interface, you need clear, unambiguous annotations. If you are writing an extended 8-mark response, you must use proper paragraphing. Here is a golden rule. Never ever bullet point and evaluate or discuss question unless the exam specifically tells you to do so. Why? Because bullet points inherently lack the connective tissue, the logical flow, required for deep explanation. Using the correct, structured format proves to the examiner instantly that you are a rigorous, detail-oriented candidate who actually understands the discipline of computer science. Let's step into Section 3, Advanced Critical Analysis. But wait, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's jump into our interactive workshop. Get ready to think fast. Top-scoring candidates, the ones grabbing those A stars, master comparative analysis. They do this by always identifying similarities and differences, and crucially, they use comparative connectives supported by hard evidence. We're going to do a quick challenge right now. Challenge 1, the data scan. I want you to picture a complex data chart right in front of you. It shows error rates in a system using only validation checks on one side versus a system using both validation and double entry verification on the other. You've got 60 seconds ticking down in your head. What is the core trend you need to extract? If you just look at it and think, oh, errors go down when they use both, well, that's superficial breadth. That's a low-tier answer. You need analytical depth. A top-tier analysis doesn't just state the obvious. It uses comparative connectives. It sounds like this. Whereas validation solely prevented illogical data types from entering the system, the implementation of double-entry verification significantly reduced human transcription errors by 40%. This demonstrates that while both methods act as data filters, verification is absolutely essential for raw source-to-system accuracy. Do you hear the difference? You must identify the relationship and draw a concrete, evidence-based conclusion. This table right here is your cheat sheet for evaluating evidence quality. You have to question assumptions, identify limitations, and prove how they affect your final conclusions. Let's run challenge 2, find the flaw. I'm going to read a sample paragraph from a mock exam, and I want you to act as the examiner. Find the sentence that is leaking marks. Ready? Here we go. The company should implement a length check of exactly 11 digits for the phone number field. This validation rule will ensure all customer data is completely accurate. Therefore, the database will have no errors. Okay, where is the flaw? Did you spot it? The fatal flaw is in the assumption. The sentence claiming the rule will ensure all customer data is completely accurate is entirely false. It's a massive leap of logic. A length check only ensures the data is 11 digits long. That's it. A customer could literally type 11 random zeros, pass the validation check perfectly, and the data would still be completely useless to the company. A truly great A-star answer identifies this limitation clearly. You would write, a major limitation of the length check is that it cannot verify the authenticity of the phone number itself, falsely assuming that any 11-digit string is a valid contact. Bam, that proves to the examiner that you truly understand the boundaries and limitations of the technology. And for challenge 3, I want you to practice speed writing later. Give yourself exactly 30 seconds to write one perfect PO paragraph based on that flaw. It will change the way you write under pressure. Finally, let's dive into section 4, top examiner warnings. This is the trapdoor you need to avoid. We have scoured years of Cambridge data, and we've isolated the top 3 fatal traps consistently highlighted year after year in principal examiner reports. Trap number 1, using the wrong approach for the context. For example, if you recommend a check-digit validation rule for a person's first name, you are demonstrating severe technological illiteracy. Check digits are mathematical calculations meant for barcodes, ISBNs, and account numbers. They do not work on alphabetical text strings. It shows you memorized a term but don't know how it works. Trap number 2, forgetting format and presentation. If you write a massive full-page block of text with absolutely no paragraphs, it is physically impossible for the examiner to follow your logic. They are marking hundreds of papers. Make it easy for them to give you marks. And trap number 3, honestly the most common heartbreak of all, answers not specific to the context. Listen closely. If the exam scenario is about an airline booking system and your answer just talks generally about saving time and money without ever mentioning passengers, flight codes, passport formats, or ticket pricing, you will score 0 for application. 0. The context is your anchor. Never, ever let your answer float away into generic, memorized textbook definitions. To make sure you actually lock this all in, I want to give you a powerful memory hack. We've created an acronym for these factors so you can instantly recall the correct analytical framework when you are sweating under exam pressure. Just remember the word valid. Let's break it down. V stands for verify the command word. Before you do anything, ask yourself, is it describe, explain, or evaluate? A stands for apply the context. Who is the actual user in the scenario provided? L stands for logic and rules. Which specific validation checks actually make logical sense here? You wouldn't use a range check on a surname. I stands for identify the limitations. What does the check not catch? Remember the 11 zeros in the phone number. And finally, D stands for double-check formatting. Are you using your PL paragraphs and clear technical terminology? The next time you sit a mock exam, when you turn the page and see a 10.1 data entry question, I want you to literally write v.a.ld lightly in pencil on the side of the page. It acts as your procedural checklist and grounds you instantly in a successful blueprint. So here is your final system recap, the 3 rules that guarantee top marks. Number 1, strict command word decoding. Number 2, flawless PL framework application. And number 3, utilizing a time management matrix to plan your answers before you write. Implementing these strategies transitions you from a panicked student relying on rote memorization to a cold, calculating critical analyst. Take a look at the blueprint we've put today. How will you adapt your exam strategy to prioritize analytical depth over superficial breadth in your very next paper? Take this blueprint, apply the evidence, and go engineer your A-star. And before you go, listen up. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.